Thompson Observatory. Do we have anybody who this is the first time that they've been here? Awesome. Excellent. Oh, you guys too? Very good. Well, my name is Glenn, and I'm one of the volunteers here. We have a bunch of volunteers who make this place possible. Would our volunteers raise their hands, please, so you can see we're just a bunch of regular folks. And in fact, what you see was constructed by volunteers too. We are so happy to have you visitors. So since we've got some folks who've never been here before, let me do a really quick recap. The Little Thompson Science Foundation was formed in the late 1990s because there was going to be an awesomely cool telescope that was going to become available if an observatory was built for it that the public could come to. And so the 18-inch scope that you'll see up in that dome was our original scope, and it is why the Little Thompson Science Foundation came together to build this, because then that would be lent to us, and I mean lent. Just by your visiting, you help us because we have to report how many visitors we have each year and how many volunteers we have each year. So thank you so much for coming. They liked what we've been doing with it enough that they let us keep using it. And in fact, have we passed, I'm not sure where Murtagh is, have we passed 55,000 visitors yet, Murtagh?
I have to update the
We're
data.
really close. The 55,000 might be in here, we're not sure. But that's pretty awesome.
Speak up if you are, though.
Okay. Pretty neat piece of history is you'll see the stripe on the floor. When the observatory was first built, that's where the wall was. And they figured if you build it, they will come. And then they'll get bored unless fewer will come and fewer will come. Well, we had the opposite problem. People came, and more people came, and more people came, and it was like, wow, we gotta expand it. So that's where the original wall was. So you get to see the expansion, and it was like, well, if we're gonna expand it, why don't we put on a second dome, just in case, or prepare it for a second dome? And so you'll also get to see the awesome telescope that we have up there, the 24-inch, and we have a wonderful 6-inch refractor that is incredibly crisp and clear that's been added to that dome. We have a solar scope there. We have so much cool stuff to see and to look through. We are so glad you're here. Now, did I mention that we are volunteers? We're always looking for new volunteers. Unfortunately, we also have to grovel for support. So, since we are on the grounds of the Berthoud High School, they have provided the grounds, but we had to build the building and we have to keep it running. So, just to let you know, if you like what we do, the gift shop for donations is always open. Our treasurer there is showing off the donation box. And so we have many, and yes, we can take your donation on the computer now, so you don't
Credit card, debit card.
Right, you don't even have to have
I
cash.
don't have that cash.
But we even like volunteers even better. So give us
My
yourselves.
volunteers with money, too.
Yeah, we'll take money. He'll take money. He'll take money. Did I cover the required things?
Training.
Training, yes. Okay, so if you are so jazzed by what you see tonight, believe it or not, tomorrow we are having, I think, our quarterly volunteer training. Is that correct?
Yep.
So if you miss tomorrow, sorry, you got to wait a whole another 3 months. But if you speak up tonight, you can come tomorrow and get trained. Okay?
Or just show up at 10 o'clock tomorrow morning.
Okay, fine. Droppings. Any other items before I introduce our speakers? For
You talk about the bookmarks and the cups and the stats and everything else too, so.
but Vanna.
Vanna.
Okay. Yes, that's right.
You have to model them.
Okay.
Sell it.
Wouldn't you look good in one of these? Okay. There you go. Thank you.
They are adjustments.
Oh, I should say that although this is a public night, public viewing night that we have every third Friday of the month, except we are closed in July, which is our maintenance, that the LTO is thrilled to host your private groups, be it a church group, a scout group, a family group, students who are studying astronomy and want to do some research. If you go to our website, starkids.org, you will see a calendar there where you can sign up for your own private night and let us know who you'll be bringing and what you'd like to do. And as I explained on one of those nights, it's just like we're regular folks. We're not, and we're just the taxi drivers. You tell us where you want us to go and we'll do our best to take you there. However, on one night a month, the third Friday, we bring in really smart guys who know what they're talking about. And so, no pressure. No pressure. But we are lucky that this is one of those nights. Tonight we've got Bill Murtagh and David Stone, who work at NOAA in Boulder. That's National Oceanic and Atmospheric Administration. They work in the group called the Space Weather Prediction Center. And it's like, yeah, what do you need space weather for? I mean, our own weather is enough to keep track of, right? Well, space weather impacts our everyday lives in ways that we may not even realize, because it affects things like the power grid, GPS technology, including your cell phone, communication systems, aviation, even where the planes can fly when they're going across the pole. And there's many things that you use it for in your everyday lives that you may not realize how it depends upon what's happening up in space. David Stone is responsible for software program there which processes the data that comes in from the space weather and makes the data plots that the forecasters use. He's leading a development team that is working on critical forecast tools. His latest team efforts are that the public space weather website, which now only gets 5 million visitors per day, they are preparing it to take up to 50 million, because that may become a lot more important to our lives. Very luckily, David also was kind enough to be a tour out there. By the way, NOAA has awesome weekly tours for the general public. So definitely, if you like this sort of stuff, go out to Boulder on their weekly tour thing and take it, because I was lucky enough on one of those tours, I had David as our tour guide, and I just can't stop talking about the LTO, and he said, hey, would you like us to come sometime? And that's how we were lucky enough to get David and Bill. So please welcome David, and David will introduce Bill. Thanks so much.
Thank you very much, Glenn. Good evening, happy Friday, and welcome to the observatory. As Glenn mentioned, my name is David Stone, and I'm on the science side of the house at the Space Weather Prediction Center in Boulder. I work with teams really receiving the ingest telemetry from the satellites that are monitoring the sun for its space weather conditions, turning those into products, and developing applications for the forecasters to use those products to understand current conditions and then predict future events. So those future events and that insight we can get, and as much notice as possible, has us generating products that are warnings and alerts for industry, for government, for an international community that cares. Because we've seen the sun in the past give off some significant storms. And in this day and age, and technology as it is today, could have some really monster effects if it were to hit us if we were unprepared. I want everybody to run and scream in this room tonight as you hear about some of the events that have passed. Our center is working to lower the impacts, to prepare nations, including this one, and developed countries, for the infrastructural effects that can happen. Now, I wear two hats at the Space Weather Prediction Center. I wear, despite the haircut, a very nerdy tech hat, working with software developers in our little caves, working on code. It's a tremendously exciting environment to work with because you're constantly learning. And for me personally, it's the closest I could actually get to outer space without trying to be an astronaut. Right? I try to be as smart as I can, but I'm not smart enough to qualify for that program. I didn't start early enough. So, shameless plug, school makes a difference. Please, if you're interested in this subject matter, I behoove you to try to explore it, learn about it. It's so captivating. Right now, it's on the forefront of impacting our society, impacting technology and those phones you're using today. The other hat I wear is a bit of a volunteer hat. I'm a fledgling tour guide, roped into giving the public tours of both our NOAA facility, which is pretty interesting, and specifically our space weather lab, where forecasters are on duty 24 hours a day. It's the only lab in the country that does this. It's one of the few labs in the world that is setting precedent, is being listened to, writing doctrine on preparedness. To speak about preparedness, I thought I would get, instead of a nerdy guy who trips over his own words like I do, I'd ask our program coordinator for the Space Weather Prediction Center, Bill Murtagh, to come in and speak. There is no more knowledgeable person in our center. No person who spends more time on the road at the White House with industry, briefing and preparing our country and an international community for one of these storms that could hit us, one of these Katrinas that could come, and to give us some prediction and some response, handling capability. Those organizations, the power grid, for example, could actually reduce the effect and respond in time, even if we had a catastrophic event happen. Again, please don't run screaming from the room. If you hear about some of these events, we're trying to work diligently to control those impacts. I have to say personally too, I invited him because he's such a gifted storyteller. I hope you enjoy his accent as much as I do. Please join me in a warm welcome for Mr. Bill Murtagh.
The accent he's talking about is a little bit of an Irish brogue. I grew up in Ireland and was actually in the US Air Force for over 20 years and been in the United States essentially since 1979 and never quite lost all the accent yet. So it's a sense of amusement for some people when they hear that accent. I want to thank the LTO staff for having me here. It's certainly a great opportunity and I certainly appreciate the opportunity. I'm a little bit embarrassed though, because I am from Berthoud and this is my first time here. I was going to lie to them when we had dinner earlier tonight. I said, yeah, I've been there plenty of times, but I have to tell the truth to them. And we've got a great setup here, and I'll certainly become part of this now and welcome the opportunity. Some of the students back there know me too, not because they know me personally, but they know Coach Murtagh, my daughter. So she's in the back there. Maggie is, both my daughters went to high school here in Berthoud. They were prominent basketball players in the high school team some years ago. Anyway, we're going to talk a little bit about space. Who in the audience ever heard of space weather? First of all, just give me some sense. Okay, just about everyone. So it's, you know, if I asked the same question, I think 10 years ago, I might not see as many hands. It's just in the last 10 years or so that we've really got to understand that this space weather stuff is not just geeky science, it's actually an issue that we need to be concerned with. It's, I suppose a kind of a cute story I could start you off with. When I learned that space weather had now reached the forefront of, well, in the political world, in our elected official world, our decision-making world, I was in the operations center back in March of last year. We had our first decent outbreak of space weather. Things were pretty hectic. We got a lot of media calls, a lot of different customers, airlines and whatnot calling, asking us what's going on, looking for some predictions and whatnot. Then I get a call and somebody said it's from NOAA headquarters. I'm part of NOAA, National Oceanic and Atmospheric Administration. I did not want to have to talk to our NOAA people at that point in time. I thought it was something administrative they wanted. But they had a couple of questions related to the space weather activity. And I was rather frustrated, and I said, who wants to know? And they said, the President. I said, the President of what? The President of the United States. I said, well, this guy is okay. And that was reality. I learned a lot in the past couple of years since that incident, that there's a thing called the PDB, Presidential Daily Briefing, where our President gets briefed on national security issues and things of interest to the nation. Space weather is part of the PDB now. So it'll just give you an idea of how this issue of space weather has been elevated. And it's largely, I said about 10 years ago, but not knowing so much about this. What happened 10 years ago, some of our scientists started looking back at some of the big events of the past. 100 years ago, in particular 1859, there was a big storm in the sun, we called it the Carrington event. And they looked at it and they recognized that, wow, this thing was about 10 times bigger than anything we've ever seen before. So the next logical question that should be answered is, okay, if something of that magnitude should happen today, what would the consequence be in our nation? So the engineering teams got to work then and started looking at that. And their answer to that question was rather astounding. They suggested, should an event of that magnitude occur today, the impact of the nation could be catastrophic. So I'm going to give you a little bit of detail. That's why we use this term Space Katrina. Everyone's familiar with the Hurricane Katrina and what it did to this country. We're concerned about a space weather Katrina. Recognized as part of the National Weather Service, we moved into the National Weather Service from the Office of Atmospheric Research about 6-7 years ago, again in recognition that space weather business now belongs in a organization that issues alerts and warnings for the nation. So the National Weather Service, of course, issues alerts and warnings for tornadoes and hurricanes and that kind of stuff. But now the Weather Service is issuing warnings for space, for radiation storms in space and geomagnetic storms, and that's what we do. So over the course of the next 45 minutes or so, I'm going to talk about a little bit more about the growing interest in space weather. Because it's just not just this interest in an extreme event. Space weather, like regular weather, occurs every day. We've got customers by the thousands getting this information daily and using it, and I'll explain a little bit about that. And the solar cycle, we can't talk about space weather without talking a little bit about this solar cycle. And from that, you'll get a sense, and I've already kind of introduced it, why we're worried about this extreme event. And then I'll just jump into the different types of space weather. Space weather is like regular weather. In regular weather, we got hurricanes, tornadoes, blizzards. In space weather, we got different types of space weather too. So I'll show you the different types, and I got a couple of animated movies to show you just how this thing unfolds. Pretty neat. And if you guys can, if the younger ones can last till the very end, I've got a whole bunch of neat little gifts you can take away with you. DVDs, calendars, cool pictures, and stuff like that. So, let's talk a little bit about this customer base. This is bear with me here. This plot, if you look at the vertical axis, that's sunspots, the number of sunspots. So we go through this thing called a solar cycle, just like the hurricane season. We know we don't see hurricanes much in January, February, March. We do the same thing at the sun. We've got a sunspot cycle where our last sunspot maximum was back in 2000, 2002 time frame. And then the sunspots kind of go away for a prolonged period, very boring at our operations center for 2 to 3 years without very little happening between 2008 and 9. And then you follow that black line and it starts rising again into the next solar cycle, the next maximum. And all very simply, what the solar cycle is this. The sun, like the Earth, has a north pole and a south pole, a negative and a positive polarity, like a magnet. But the sun does something a little freaky. Every 11 years, it does a switch of the magnetic field. The negative goes to positive and positive negative. During this transition process, these things appear in the sun called sunspots. And the sunspots are that visible manifestation of the magnetic fields doing this twisting motion as this whole 11-year process is underway. So we call it solar maximum, when we get lots of sunspots, and then the magnetic fields get established, and we go to solar minimum, no sunspots for a few years, and it starts all over again. But what I wanted to show you here more than even about the solar cycle is you see the shaded blue area, that's our product subscription service. We introduced this back in 2005, where you can sign up for alerts and warnings. It's a free service from government service, from the National Weather Service. But you can see, right through solar minimum, when nothing was happening, we were getting several hundred customers signing up every month. And of course, as the activity increased and ramped up, we saw the customer base. Now we're seeing as much as 1,000 new customers every month. You say, okay, Bill, what kind of customers are we talking about? And you'll see them here. Just a kind of a snapshot, a cross-section of the types of people and companies and sectors that are using space weather. There's a couple of interesting ones here. The State Department of Transportation. Every State Department of Transportation is using this information. Let me give you a story why. I was up in Alaska last year with the Alaska State Department. You guys ever see a snow plow? In Alaska they got snow plows too, because they got a lot of snow up there. And they got this road called Thompson Pass. It goes into Valdez. And they get about 500 inches of snow every winter. That's a lot of snow. They got to bring the plows out. It's the only way into Valdez in the wintertime. They bring the snow plows out. They close off the roads to the public. The snow plows are going up the road. Zero visibility. You can't see. It's like a blizzard. 1,000-foot drops either side. And these guys are driving, doing 20, 30 miles an hour. And guess what? They're not looking out the window. They're relying on GPS. It's a new system. GPS is projected onto the windscreen, and they're just watching a map. And it's got a triple redundancy system. I love this. It's got a green, red light, and if you go just about 10 inches too far left, goes red light on the left. You have to bring it back just a little bit. It's also got an audio, so it starts beeping if you're 10 inches too far left or too far right. And the third piece is kind of cute. It's got a vibrating seat. They call it a seat shaker. The seat shaker gives you a little jiggle on one side and you're too far. Jiggle on the other side. So that way you can't fall asleep at the wheel. I guess it's better than an electric shock, right? These guys, this is life and death situation. Because I mentioned there's 1,000-foot drops there. When we have big space weather storms, just brilliant system we have, GPS, that is so accurate, right down to centimeter accuracy. Not the case during space weather storms. In some situations, we have several, in what we call a single frequency GPS, it can be off by as much as half the distance, half the length of a football field. On the more sophisticated systems like these guys are using, it would never be that far off, but it would be off by about 10, 12, 15 feet. That's big when you're driving a thing up the highway at 30 miles an hour and zero visibility. So it's just an example. And when you look across the board here, to John Deere and Caterpillar, why do those guys want space weather information? You guys know what John Deere is, right? All the farming, the tractors. Why do these guys want space weather information? Precision agriculture is huge now. It's about a $10 billion industry in this country last year. So now the folks out there in those fields and big farming equipment are using GPS to plant seeds exactly where they want them to go, and they know exactly where they want to go. So when they come back behind the next day and they want to irrigate, and they want to water it, and they want to fertilize it, they know exactly where the seed is and they spray exactly where that seed is. So it's tremendously efficient. And of course there's one other thing they can do with that that's excellent. They can do it 24 hours a day. Because it doesn't matter if it's dark outside when you're relying on a GPS that you know is accurate all the time, as long as there's no space weather. So those guys will get all our alerts and warnings, so they know not to be relying on GPS in the middle of the night during a space weather storm. So again, you'll see anyone involved in aviation, flying satellites, all customers now of space weather, because it impacts the various technology. Now, I'm going to get through this one quickly, because that's another plot. But as you get that vertical action, you can see the sunspot, and here's where we're at in the next sunspot cycle. It's going to be considerably smaller than our last sunspot cycle. So it's kind of weird. In our business, it gets kind of boring when we're not seeing much activity. But that's the case. It's going to be less activity because we have a smaller cycle. In fact, if we look back at the last 250 years of sunspot cycles, look at this dashed red line, that's the average. You'll see well, shoot, for the best part of the last 6 or 7 cycles, we've been at or above that average. So we have to go back essentially to this cycle right here, back around 1906, 100 years ago. So that's the kind of cycle we're expecting now. It's going to be smaller. So the obvious question I get when I go to Washington, and I'm in the White House or elsewhere, and they're asking me, well, we much to worry about, Bill, if it's going to be a small cycle like that. And I say yes. And I say that because you see the 2 arrows there? They're highlighting 2 of the cycles that are actually a little bit smaller than average, but they're highlighting the cycles that produced the big storms, the Space Katrinas. One of them was the 1859 storm, the other one was the 1921 storm, mega superstorms. That 1921, we haven't done anything like that since 1921. These are the ones we've studied. And you might say, Bill, how on earth do you guys know what the 1859 storm looked like? We actually had the technology back then to measure Earth's magnetic field. This thing here, this green plot, September the 2nd, is an old faded plot from the Kew Observatory in London from 1859. So we actually have the measurements of the magnetic disturbance then. The 1921 storm, just I like to look back in the history books at this, and I look back at the New York Times, and even then the technology of today was being impacted by space weather. And you can take a look here, you'll see that particular storm in 1921, the entire signal and switching system of the New York Central Railroad below 125th Street put out of operation, followed by fire in the control center due to a space weather event. The electrical currents that were formed and flowed through the lines into the telegraph stations and whatnot, into the signal stations, caused fire. When we talk about space weather, and I talk about geomagnetic storms, what's the beautiful part, the beautiful visible piece of space weather? Aurora Borealis, right? Aurora Borealis is the northern lights, and the Aurora Australis is the southern lights. I remember getting an email a few years back from someone in Sydney. They asked me if there's any chance that we're going to see the Aurora Borealis tonight. Think about it. No, you might see the Aurora Australis. Our friends up in Canada and Alaska are used to seeing the northern lights. In 1921, what do you think the folks in Cuba and Jamaica thought when they looked up and saw the northern lights? It's a reflection of just how intense the geomagnetic storm was that the northern lights were visible all the way now, almost down to the equator. It's one of the ways we can track back on the big events of old by looking at the mariners of old when they sailed the seas would always identify the weather conditions that they're given latitude and longitude, and they would also provide information on the northern lights. So we've got a good history. There was lots of recordings of the northern lights all the way down in Florida, down to Jamaica, Cuba, and whatnot. So let's just I just kind of introduced the space weather piece and why people are concerned. You see all the different sectors impacted and whatnot. Let's take a look at the different types of space weather now and show you a few examples of what it looks like and the customers impacted. So when we talk about space weather, this is our one science slide really here. We're talking about 3 different types of emission from the sun. The electromagnetic radiation across the spectrum. So if you remember our high school physics class, we've got our gamma rays all the way down to the very long radio waves and everything in between. The sun emits across that spectrum. Speed of light only takes 8 minutes from the sun to the earth for the speed of light, 93 million mile transit. The other thing we're worried about is energetic charged particles, the electrons and protons. And the third piece is really the key piece. It's magnetic field. If you guys put 2 magnets together, what happens? They get stuck, or they push apart, don't they? Depends, right? That's what happens here with the sun. When these big explosions occur, its magnetic field is like shooting out a magnet into space. So now I got this magnet flying through space, sometimes towards the Earth. And what does the Earth have? A magnetic field as well. So that's a magnet. There's a magnet coming out from the sun. Those 2 magnets are going to interact. And how they interact is going to dictate how strong the storming is. So remember that. We've got 3 different types of emission. And we've introduced these space weather scales some 10 years ago, just to zoom in on them. They're actually here if anyone wants a copy before they leave. And they're essentially modeled after something that the citizens understand in this country. People know what a F4 tornado is, a Category 5 hurricane. So we produce these on a scale of 1 to 5, with 5 being the extreme condition, and they essentially cover those 3 types of emissions I just talked about from the sun. So let's talk about the first one, a solar flare. Anyone ever hear of a solar flare? So when we get the sunspots, right, we want to see if there's going to be a solar flare. Is it apparent on that image where the solar flare is? Yeah, that flash bulb you see there on the left-hand side. And what I'm going to do is I'm going to ask David to put it into motion, and you'll see if you're sitting in our operations center, here's what this looked like that day. So things were very quiet on the face of the sun. I had this bright area coming around the sun, and all of a sudden, wham! That explosion is huge. We're talking about 100 million hydrogen bomb type energy, all at the same time from this massive eruption. We got X-ray, we got these sensors on board our spacecraft. I know that's just a boring looking plot, but when I see that big jump, this big increase, that's the X-ray emissions from this flare. So that's what I'm measuring in the operations center to understand how big and how bright that is. I mentioned speed of light, it only takes 8 minutes to get here, and it impacts lots of our technology. Anyone here use GPS? Almost everybody uses GPS. GPS will get impacted by the solar flare. Communication systems and radar systems will be impacted by a solar flare. Now I'll give you an example of how it impacts aviation. This is kind of interesting. So you can see the big flare up here, and I'll put it into motion in just a minute. But if you can see, right there in Central America, there's a little yellow dot. It's what we call the subsolar point, where the sun was shining at this given time of the day when this flare erupted. This plot shows a frequency range we use called the high frequency range, HF. All our emergency, the hands, if there's any hands in the audience here that use HF, they know all about it. The color scale here represents the frequency range up to about 35 megahertz. When this flare, the HF frequency is very good because we've got this layer of the atmosphere called the ionosphere, where we can bounce the signal off the ionosphere, off the ground, up and down, so you can account for the curvature of the Earth. So you can communicate with an aircraft or with an emergency response community hundreds or even 1,000 miles away, as long as no flare is occurring. Because watch what happens when a flare occurs, because the ionosphere gets changed drastically when the flare occurs. Watch from that yellow spot, anything that's in the red into the yellow zone is total loss of high frequency communication capability. So go ahead and click on that, David. Flare occurs right there. So you'll see the record, might be hard to see, but just so you'll be wondering how long this goes on for, about 3 hours. So if you're sitting there relying on HF comms, and it all happens within a minute. It just goes from a nice clear signal to scratchy, we call it a whiteout, to scratchy noise. Recognize, you say, why is it just there? It's a daylight side effect. Nighttime, you're okay. Daylight side effect. And you say, who uses this? The communication centers in the airlines use this all the time. Because if you're flying over the Atlantic, over the Pacific, over the poles, this is the type of communications they rely on. HF communications. So they must know, is the aircraft having communication problems? Is the aircraft in distress? Is the equipment having problems on the ground? Or is it a solar flare? They must know, critical for situational awareness. And that's the kind of reports we get from these folks. This is from the communication center, so they will describe this as a severe operational impact. So we talked about it impacting GPS. Let me show you a great example in this little movie of how it impacts GPS. Again, you can see where the flare occurred, a fantastic bright area in the limb. This image you see of the Earth here, with all the green dots, are GPS receivers across the world in a particular network called the International GNS Service. Doesn't matter. All you got to know is green is good. Green means you're receiving the signal. GPS is fine. Red means you are not. We use the term denial of service. When this happens, you can no longer receive the GPS signal. GPS receivers are down. Now what happened on this particular day, here's a quick GPS 101. We've got 20 plus satellites up in orbit, what we call a middle Earth orbit, all sending signals down on a given frequency. The frequency happens to be 1.2 and 1.6 gigahertz. Doesn't really matter, except that's how it works. But the sun is emitting at 1.2 and 1.6 gigahertz too. Always a background noise. But on occasion, when these big flares occur, they emit 1.2, 1.6 gigahertz emissions. And the background levels, and we measure these levels, typically we call them solar flux units. The background levels are typically about 100 solar flux units. So we engineer around that problem. It's just noise in the background, but when a big flare occurs, as was the case in December 2006, the background went from 100 solar flux units to 1 million. We never thought it could happen. We built most of our operational equipment to measure up to 200,000. So it just went up, flatline. And we had at Owens Valley Research Institute in California have an instrument they were able to measure it. They called us and said, Bill, you guys screwed up a little bit. You should have got your instruments to measure it 5 times bigger. It was about 1 million. So what happened? So picture your signal, which is typically right above the noise. All of a sudden the noise is up here. Your signal's buried in it. You can't use your GPS then. Short-lived, but watch what happens. Again, it's the sunlit side. Put that into motion, David, and you'll see the little dot here tracking the 1.6 gigahertz. Not much happening, not much. You can see where the burst is right here. And you see all the reds. So it's losing the ability. Now, if you're driving on the highway using your TomTom, get over it, right? An inconvenience. But if you're landing a plane in a 1/4 mile visibility, a crosswind or a dangerous weather situation, and you're relying on GPS and it's not available all of a sudden, we've got a big problem. So the FAA are very knowledgeable about this issue and are taking the appropriate steps that we will never get into a situation where we're totally reliant on GPS and something like this occurs. That was the first type of the 3 space weather types, right? The next type is the solar radiation storms. We get the flare. I have another sensor that's measuring the energetic particles, the protons. You can see the increase. That's all you got to know. Big increase, several orders of magnitude. It takes 30 minutes to several hours to get here. And this is not just a couple of tens of minutes to hours. This can go on for days, these radiation storms. And now I've got a whole different customer base that are concerned about this impact. Satellite operators, aviation, high latitude HF communication outages, and NASA are primary customers for this information. And let's talk about why that is with a couple of them. If you're flying from the United States to China tomorrow, what route do you typically go anymore? Over the pole. Yeah, so now that we've got the Airbus 340s and the Boeing 777s, these planes can fly for 16, 17 hours straight. There's no big thunderstorm outbreaks over the North Pole, so you don't have to worry about that. It's jet stream winds, not a big issue either. Their biggest concern flying over the poles is what? Space weather. The radiation storm levels. If we hit, remember the scales I had, 1, 2, 3, 4, 5, 5's the extreme. If we hit the 3 level on a radiation storm, they're out of there. They start rerouting those flights away from the poles. The radiation follows the Earth's magnetic field lines, focuses in on the polar regions, and it messes with communications, it messes with the navigation, and with the rather delicate, awkward part is it creates a radiation exposure concern as well. So the airlines don't even want to deal with it. I thought it was cute. Mike Stills is the chief dispatcher of United Airlines. I talked to him last year. I said, Mike, so when we give you guys one of these warnings and you reroute the flight away from the poles, radiation storm, I said, what do you tell the passengers? And he says, Bill, you can be darn sure I don't mention radiation. I said, yeah, I get that. What they actually tell them is it was weather. Just won't go into too much detail. Just so everyone knows too, there's an example of the big increase, the surge of the protons coming in, and just comments coming back from the airlines. For days in a row, they're having difficulties with high frequency communications. NASA space flight is a big one. These guys are flying on the International Space Station at low Earth orbit. They're only a couple of 100 miles high, well within inside the protected cocoon of Earth's magnetic field. They're all right. They're going to be safe, the astronauts on the International Space Station. But what if we go out to the moon? or Mars, a whole different cup of tea then. The Earth's magnetic field and the Earth's atmosphere provides a tremendous amount of protection from this harmful radiation. We do not get that when we get into deep space outside the Earth's magnetic field. One might ask, so what about the Apollo years, Bill? The Apollo years, we got lucky. That's the bottom line. And luckier than most realize. Anybody remember back the Apollo 16 and 17 missions in 72? One of them was April, the other was October, right in between, August, the biggest radiation storm we ever measured. By some estimates, had that radiation storm occurred when the astronauts were on the moon, it would have been lethal. They would have made it back home and died about 2 weeks later from radiation poisoning. So back then, we knew there was a big radiation threat, we weren't sure just how much, but you know, we were politically driven too, weren't we? We didn't really care. We were going to get there first. In the Space Weather Prediction Center, we actually do weather supports. One of my favorite things at the moment, tell my mother in Ireland. So I'm doing weather forecasts for Mars, Mom. So she can't get over that. But we actually do weather forecasts for Mars. Any of the missions going to Saturn, into Mars, whatnot, we have to provide the forecast of radiation levels, the magnetic fields, magnetic storms and whatnot, to help those folks understand what the spacecraft might experience when they're flying into the Mars orbit. So the last piece then is the geomagnetic storm. We've talked about the solar flare, radial blackouts, and the radiation storms, and this last piece is the geomagnetic storm. So we got the big flare, we had this radiation storm. Now I turn my attention to these instruments called coronagraphs, where we block out the sun. We create an eclipse. We have instruments in space called coronagraphs. They block out the sun. So now I want to see what's happening in the corona. Picture this. You watch, you see an explosion. The first thing you see in an explosion is the flash of light. Hear the sound, and then the debris falls out. What I'm looking for here is the debris. The debris is big. It's about 1 billion tons of plasma gas and magnetic field that can get shot out into space. We call them coronal mass ejections. David, click on this one, I'll give you an example of a coronal mass ejection. Watch this. That little dot right there is about the size of the Earth. Put it in motion again and watch the structure, because that's the magnetic field escaping it. Go ahead and click on it again, David. That's the thing, when that's coming towards us, then we get worried. These things happen fairly regularly. Space is big. Many of them get shot out in every different direction. Sometimes they get shot out right towards the Earth. When they get shot out towards the Earth, it's a little more boring looking on the image here, but this is a black and white occulting image, and we put this green loop on it, this green circle on it, to measure how big, the rate of expansion, and to determine how fast it's coming, and recognize it's coming towards Earth. So put that in motion, and you'll see, again, it's not as dramatic, but there's the material blasting out. It's coming right towards us. That one is beautiful. This is the one I'm worried about. That one is shooting out that direction. This one is coming towards the Earth. They think about, that's the one good thing about these. They are the thing we're worried about the most, these coronal mass ejections and the geomagnetic storms. But the great news here is these things are moving slow. They're moving about 5 million miles an hour. It's all relative, right? To the speed of light. Only took 8 minutes for that first stuff to get here. But this thing, if you do the math, if it's moving at 3, 4, 5 million miles an hour, it's got 93 million miles to go. It's going to take a day or 2 or 3 days to get here. So when we see something coming right at us, and we did this morning, we've got warnings out for a geomagnetic storm at the G2 level on Sunday. We saw something like this occurred early this morning, about 5 o'clock this morning. When we see something like that coming, we get this watch out and give everyone a heads up that there's a potential for a geomagnetic storm. So just like a hurricane sitting 48 hours off of Miami, they issue a watch, it's going to hit the shoreline somewhere along my Florida coast. We're doing the same thing here. We're going to issue a watch. And we've got our first model in space weather, and this is how it works. When we plug this information, when I put that circle on, measure that CME, this pinwheel, you see, if you look at the dot in the middle is the sun, that's the Earth. These are 2 different spacecraft here. And this colors that you see coming out is the solar wind. The wind is always blowing out from the sun. And if you had a hose with the water running and you did that over your head, you know the way it swirls around? That's the way it's coming out here. See, it's swirling around as the sun is spinning. Blue, greens represent increases and decreases in solar wind speed. But it's going to be very obvious when we plug the information that a coronal mass ejection just occurred. This thing's going to help us understand when is it going to get here. So go ahead and put it into motion and just watch what's happening in the sun here. There's a couple of small puffs come out and then the bigger one right there. See it moving out, bam, hits the earth. It's projected here, it tells us when it's going to hit the earth. So now this thing is pretty good. It's about this long. It's about plus or minus 6 hours, which is decent. When we're talking about something that can take 40, 50, or 60 hours to get here. So now we can provide customers a heads up that it's just like we did this morning. On Sunday at 9 o'clock in the morning, plus or minus 6 hours, we're expecting a geomagnetic storm right here on Earth. A boring plot, but I have to show it because it's so significant. The coronal mass ejection left the sun and it's making its way to Earth. It's got a long way to go, 93 million miles, but about 30 or 40 hours later, it gets here. And I've got this buoy out in space called the ACE spacecraft. It's great. So it sits out there 1 million miles out towards space, towards the sun, measuring the solar wind speed. And look at this boring plot here that's so important to us. It says 350 kilometers per second. That means the wind speed, current wind speed in space is about 800,000 miles an hour. Pretty windy. 800. And what happens right there? Big jump. The CME just hit the spacecraft. So now I can see how fast the CME is going. I can measure the magnetic field, the temperature, the density, everything I want to know inside that bubble of gas that left the sun. I can now figure it out because of this spacecraft. And it gives me about 30 to 45 minutes warning time before it hits Earth. So I'll issue an imminent warning. If it hits the spacecraft, it is going to hit Earth. I'll get that warning out. All the people that need this information will do what they can with it. And this is actually a magnetometer, and there's a big deviation, so it hit Earth's magnetic field. It takes 20 to 90 hours to get here, and it can last from hours up to a day. So I'm just going to put it into motion to finish this piece up, and this is a nice animation here of how it all works. Go ahead and just click on that. And there you can see the sun, and keep an eye on this area right here, guys. There's going to be a big eruption right here, and there it goes, making its 93 million mile transit all the way to Earth. It's going towards the magnetic field, and wham, hits the magnetic field, compresses, it causes all sorts of problems to our satellites out here. We call that a reconnect. The magnetic field lines are coming in, and it injects a whole bunch of messy material, particles of electrons and protons into the North Pole. And what do we see? The Northern Lights. The Aurora Borealis. So that's the sequence of events and how that works. So, geomagnetic storms have all sorts of impacts on GPS and the aircraft and manned spacecraft, satellite operations. That's the one we're worried about. That's the one that has the president asking questions. What it could possibly do to the electric power grid. Before I get to the power grid, I just wanted to show you this because I thought it was a cute movie. Back in 2003, we had a coronal mass ejection, powerful, a couple of them. And they shot out into space. People say, you guys got any sensors out there in deep space? Yeah, all of them. All the missions that we have, the Cassini, the missions, the Ulysses, any of the spacecraft we've got out there, all have the ability to detect these things. So we actually put this into an animation. Go ahead and click on that, David, on the top left-hand side. Just on the image itself, the sun image itself. Now watch this from these sunspots. We had a couple of coronal mass ejections blast out. And just to show you how far they went, they moved on out, spread out, impacted Jupiter. And we actually had some of our instruments on board the spacecraft there. We were able to tell. I mean, the spacecraft, these instruments are not designed to be space weather instruments, but they get interfered with. So the information comes back to us. That coronal mass ejection went on, hit Saturn. I got all sorts of readings from the instruments. And then the coronal mass ejection continued all the way out What's the spacecraft we got out at the very edge of the system, of our heliosphere? Voyager. Voyager 1. Anyone know how far Voyager 1 is from Earth right now?
Long way out.
11.5 billion miles. It's incredible just how far it has moved. And of course, when we talk about the Aurora Borealis, we get the Aurora Borealis right down in Colorado. Not often, but here's examples from October 2011, August 2000, November 2004, and when was that last one? I can't see. 2003, right there in Boulder in the Flatirons. So the Aurora is the beautiful piece of the geomagnetic storms, and yes, we will see it here in Colorado every so often. So let's just finish up here with the power grid, because it is the big concern. When these big geomagnetic storms occur, they rattle the Earth's magnetic field, which in turn essentially induces electrical current. And this current will flow along good conductive material on Earth, and it will flow along good conductive man-made material like power lines, pipelines, power lines, railways, all get geomagnetically induced current flowing on them. And the worst, the bad situation, the unfortunate situation, is the most vulnerable place in the world perhaps to this phenomenon is in the United States, and it's in the northeast part of this country, northeast part of the continent to be more specific. And that's because of the northern latitude, the areas of igneous, the conductive and resistive rock formations up there, the proximity to oceans, saltwater, beautiful conductor of current, and of course we have to have a big interconnected grid, and we do. So we are in a very vulnerable place. And the engineering stories that came out, I mentioned earlier, suggested this. When you look at that image there of the map of the United States, and you see inside that black line, they're suggesting that a major Carrington-like flare, should it occur today, could bring the grid down in that size of area. Now, this country, we are prepared for blackouts that go on for hours and days, and on occasion weeks. We've had them, we deal with them, we get through it. This situation, we start talking about months and years, which is a whole different cup of tea. And the big distinction here is they're suggesting that the induced current that will occur will burn up the transformers. And these transformers are not something that sit out in the shed out back. These things are as big as a house, cost a lot of money, they're tailor-made for different systems. You just can't go out and replace them. If we lose several dozen or 100 transformers, we're going to have a big problem trying to replace them. The recovery time could be months or even years. Is it a 50-year? Is it a 100-year storm? We don't know. We know we had one in 1859. We know we had one in 1921. We can't say it's every 80 or 90 years based on two. But we know that they've occurred in the past 200 years. And this whole issue of the geomagnetic storm, how it impacts the grid, is not theory. It's impacted the grid and brought the grid down before, just not at this large scale rate. In 1989, March of '89, Montreal, Quebec brought down due to a geomagnetic storm. September 1990, our nuclear power plants at Salem and Hope Creek in New Jersey significantly impacted due to a space weather event. As recently as 2003 in Sweden, the city of Malmo down blackout due to a geomagnetic storm. And if you wonder what it looks like, that's what it looks like. The transformers will actually overheat and burn up. That's from the Eskom network in South Africa in 2003. So, a little bit boring, but just to share with everyone, just for comfort level, we're doing everything we can about this issue right now in the federal government. On the upper picture, the upper right-hand picture there, in the Situation Room, John Brennan, Richard Reed, Chuck Donald, Asha Tribble. They're the people we communicate with. We go directly to Asha sometimes. John just took over CIA. We'll communicate with these two. We'll be meeting Chuck on Monday. And these are the guys that brief the President, National Security Staff, when a big space weather event is in progress. We work closely with our colleagues in Britain and across the world indeed, but there are several things underway. I'm just not going to go into the details. You can ask me afterwards and spare the younger folks here some of the policy and political stuff that's going on here. But there's a lot of things happening in the federal government to address this issue now. So, I'm going to finish up on a lighter note. And I'm going to show you this picture. I want to ask, what the heck has this got to do with space weather? Anybody want to try an answer to this one? Yes. Yes. I always talk about the diverse nature of our customer base. We could be at 1 minute talking to the White House, we could be talking to NASA, we could be talking to Lockheed and their spacecraft, the DoD, whoever. Or we could be talking to the pigeon racing community or the dove community. Pigeons get affected by space weather. And I learned this, I knew a little bit about it a decade, 2 decades ago. But I learned something recently that I was really amusing. This product subscription service is great, so people sign up for the alerts and warnings. I get to see who they are, and I get a sense of why they're using this information. So I find this company, and it's called something along the lines of Celestial Doves. So I have to call them and ask them. So when I call them, I'm trying to be real professional. I say, yes, Bill from the Space Weather Prediction Center. Just want to make sure that you're getting the services you need from our operations center. By the way, what are you using it for? She says, well, we're one of the companies that release the doves at weddings. And we understand from apparently an article had been released in some kind of one of their trade magazines that during geomagnetic storms, the doves could get impacted, and it's true. When the doves are released at the wedding, you'll see them fluttering around. It's a lovely romantic thing, right? It's almost like they're doing it on purpose for the bride and groom, circling around, but they're not. They're getting their bearing with the magnetic field, and once they figure it out, they're gone home. Can't do it during a magnetic storm. Even on a minor magnetic storm, they won't fly these birds. Which is totally interesting, of course, because I had to ask the woman, I said, let me get this straight. So, the bride and groom walk out of the chapel, you're getting ready to release the bird, but Bill, if the cell phone rings and it's Bill Murtagh with a geomagnetic storm warning, and you're going to tell the bride that you're not releasing the doves at her wedding day because of a geomagnetic storm, I want to be there. Since then, I've seen several of these companies have signed up, but just not just the doves, but the pigeon racing community. Any pigeon racers here? Pigeon racing is widespread, and yet I've yet to have an audience. Maybe people are embarrassed with their hands up.
There might be a few pigeons.
Well, I've had to do my research. The people I fear the most. You know how a forecaster can blow a forecast? This happened in Boston a couple of years ago. The guy said it was going to be 12 inches of snow and it was all rain. They had canceled school. The Logan Airport was closed down. It was a disaster. They wanted to fire the meteorologist. In the space weather business, my fear are these guys. When we blow the forecast, these guys let their pigeons go and the pigeons get lost. They call it a pigeon loss. The pigeons don't find their way home. They don't get home. So I couldn't figure out why these guys get so upset. I did my little bit of research and I found an auction site for racing pigeons, and some of these birds were selling for $20,000 a pop. And the record for a pigeon sold back in 1999, $129,000. Now I appreciate it. Why? When I blew the forecast, these guys got so upset. And there's one last piece that I want to share with you that's kind of interesting in the space weather business. And I want you guys to tell me, you got the prize for the last one. Let's see if we do this one, okay? What do the following have in common? Now, obviously there's something to do with space weather here. So Stradivarius, well, Stradivarius is, there's this guy called Stradivari, an Italian guy who made violins back in the late 1600s, about 400 years ago. And they're fantastic violins. If you got one on the auction market today, they sell for over $1 million. Vandenier was a Dutch painter. See one of his paintings. The Titanic. I'm finding my favorite. Mighty Guinness. What do the four have in common? They've all been linked to extended periods of low sunspot cycles. It's the one thing, people talk about the relations, they often ask me the relationship of space weather to regular climate. We don't have really strong connections on space weather and how it might influence the development of a hurricane or a severe thunderstorm. But what we have established in large part, that in climate terms, in long-term measurements, there is an influence. So back in this period, and this is a bizarre thing that happened, back between 1640 and 1715, we had people watching the sun. Since Galileo in 1610 and others have been watching and measuring sunspots on a daily basis. So it was happening, and through this whole period, no sunspots. They went 7, 8, 10 years sometimes without seeing sunspots. They call it the Maunder minimum. We ramp up then, we started getting cycles back, and you can see a couple of other lulls. What we do recognize is that the temperatures, climate, sea surface temperatures, air temperatures, follow that trend. When we have prolonged periods of no sunspot activity, not just a couple of days or months, but I'm talking about a couple of decades of cycles like this, we see dips in our temperature. And that's reflected up here on this plot with the SST, is sea surface temperature, mapped with the sunspots. A little bit controversial because of the global warming issue. People say, well, how much of an influence is the sun actually having? So now we can go back and look at the 3 or 4 of these and establish why there's a connection here. Stradivarius developed these marvelous violins back in the very late part of the 17th century. They do sell on auction for over $1 million, and nobody could ever understand how he built them to create that marvelous tone. No one could ever recreate the tone. And there's a lot of theories why that is, and one of them is that the wood he used was the wood influenced during that cold period, that mini ice age, the Maunder minimum. So that wood was much, much denser and slower growing. Obviously you can't create that. And that's one of the theories why it's published paper on that. The second was Vandermeer. Those paintings back then, if you look at that painting, a little bit hard to tell in the dark, but everyone knows the Holland's famous for the canals. Back then his paintings always depicted frozen canals. They're never frozen. They were then the mini ice age associated with that lull in sunspot activity. The Titanic, published paper by British meteorology, the Titanic sank in April of 1912. We had a dip from 1880 to about 1920 in sunspots, not like the Maunder minimum, but a dip. The sea surface temperatures in the shipping lanes from Europe to North America were much, much colder. Remember the scene with DiCaprio? He's freezing in the water right before he went down for good. Water temperature was 32 degrees. Now the water temperature in that particular area is upper 30s, around 40 degrees. What did that mean? Well, the big icebergs that broke off from the western shore of Greenland found their way down, maintaining their size, their mass, right down into the shipping lanes. We don't see those kind of icebergs anymore. So again, the link made to the lull in the sunspot activity. And the last one, of course, pint of Guinness. Interesting paper written some years ago about how that period of the Maunder minimum influenced the drinking habits of Northern Europe and in turn North America. It was back then, parts of the 14th, 15th, 16th, early 16th century, a lot of wine drinking in Germany, England, Northern Europe. Then we had that Maunder minimum, and we had that freeze, that mini ice age for several decades. All the vines died. They had to turn to something else to get a little drop of pure. So they turned to the wheat and the barley and the hops, and it went from wine to the whiskies and the beers, and brought that culture with them to the United States. That was just the National Geographic title about did the Little Ice Age cause Stradivarius famous. So anyway, I'm going to leave it at that. The technology evolution, we put ourselves in a precarious situation because we rely so much on fantastic technology, but it is technology vulnerable to this phenomena. That interconnection of the grid and whatnot, and of course our reliance on satellites, have all put us in kind of an awkward situation with this issue of space weather. But obviously recognize that there are many, many things happening. In fact, one of them just happened yesterday with the Federal Energy Regulatory Commission mandating activities by the electric power grid in response to this threat. So there'll be blocking devices, hardening devices put into systems. So we're really on a hard push right now to make our society more resilient to this threat now that we understand that it exists. So thank you very much for joining me here tonight. And if anyone's ever interested in seeing the Forecast Center in Boulder, it's just down the road, you're always welcome. I can give you my contact information. I'd love to give you a tour. So thank you very much. Want to take a few questions?
How about we do questions after we let the families go? How's the visibility up there now? Do we have stuff to see?
Remember, I do have those handouts too for anyone who's leaving.
Excellent.
So please,
Yes.
grab some of these.
So, we're going to open the telescopes. So people are welcome to go take a look through the scopes. And if you have youngsters, please come up here and Bill and David, will you open